Hi everyone, my name is Liam Bates. I'm the CEO of Kaiterra, and today I want to talk to you about a question that we get a lot from consultants, from designers, from APs, and from buyers who are just setting out into their IAQ journey. And that is, how do I choose the right indoor air quality monitor for my project? And I want to talk about this because more often than not, when we see people making this decision and going through this process, we see them doing it the wrong way. And this can be a very, very costly decision, both from a time perspective, but also from a money perspective. And in many cases, the way this goes is the person that's responsible for choosing an indoor air quality monitor will find several vendors, will bring up tech specs side by side and look at them and compare the numbers. So things like accuracy, range, resolution, and then choose the monitor that has the best numbers. And that kind of makes sense, but it also really doesn't. And it is not the right approach. So here's why. Let's take an example. Let's say that monitor A has a CO2 range that goes up to 5,000 ppm, and monitor B has a range that goes up to 10,000 ppm. It seems like the monitor that goes up to 10,000 ppm is naturally a better choice, and you should just go with that one. However, in this type of situation, the range of CO2 is just a tiny, tiny fraction of what you really should be looking at. And at the end of the day, 5,000 or 10,000 ppm really does not matter because both of those numbers are way too high. And you should never be seeing numbers like 10,000 ppm in any normal environment where you would be caring about CO2 levels. And so that number, at the end of the day, it really doesn't matter. But there are many, many, many other things that do matter, and that's what I want to help kind of walk everyone through today. Another risk of focusing on all of the little details in the tech specs is it may mislead you and actually overshadow some other factors that can be much, much, much more important. For example, let's imagine that you are going after the WELL building standard. You're going for WELL certification, and you want to use indoor air quality monitors as to measure the air quality parameters within the air concept. So you should initially vet a monitor for things like, does it measure all of the parameters that WELL actually requires? Does it report data frequently enough to be used for your WELL certification? What does the annual data submission process look like? How easy is it? And how easily are the monitors recalibrated? Because those are all core parts of the WELL standard when it comes to indoor air quality monitoring. So of course, tech specs do matter, and a lot of this information is in those technical specifications, but 2 or 3 or 5 sets of specifications around range and accuracy and resolution across many different monitors simply is not the right way to look at it with goals like those, because there are so many other factors that are a really critical part of it. Some of those factors, by the way, don't actually sit in the hardware. In the hardware, they live in the software. We'll talk more about this later. In this example, if you overlook some crucial details like exactly which parameters are being monitored and whether or not they are compliant with WELL, you might end up only receiving a couple points within your WELL certification for air quality monitoring, it's A08, and not actually being able to meet all the preconditions, which would then mean that once a year somebody needs to come on site and take more readings of air quality, which is going to cost you a lot of money. So I'll jump out of the weeds of WELL here. That's just one example based on one potential use case of indoor air quality monitors, but I think it highlights how important it is to understand these things and not just look at spreadsheets of parameters side by side. Okay, so we talked a little bit about how you shouldn't choose an air quality monitor. Well, what is the right way to choose an air quality monitor? And I think the most important thing is to take a step back and ask yourself, what's the big picture here? Why am I measuring indoor air quality? And this is something that we will always do when we're working with clients is ask multiple times, why are you doing this? Why does this matter to you? What are your goals? Because everyone has slightly different goals. So just like how if you're trying to get fit, different fitness goals may require different training plans. Understanding the goals of your project can help to provide sort of overarching guidelines around how you should think about selecting vendors, assessing hardware, assessing software features, and making the right decision and the right choice for your specific project. Not all fitness goals have the same training plan, and not all goals when it comes to indoor air quality and a healthy environment should use the same hardware and the same software. It's really about choosing the right solution for your needs. So we've got several examples here of goals that we often hear. Many clients will have several of these goals or all of these goals. If that is the case, try to prioritize and understand what is the most important one to you. So first up, we have building certifications. Now, if you're going after a certification like WELL or LEED, Fitwell, Reset, and if this is your primary goal, then it's really quite straightforward to narrow down the giant ocean of sensors into a handful that will be able to support your project needs. And the process that I would recommend looks something like this. Number one, parameters. What are must-haves and what are nice-to-haves? This will differ based on each certification. I've personally written a lot of content about this, so feel free to reach out if you would like to learn more about that, or just look it up on our website. There's a lot of information out there. So different certifications and even different tiers of certification, bronze, silver, gold, those will all have different requirements. So understanding what features you're going after and what parameters are needed to meet those features is step one. Number two, hardware requirements. With WELL, it's really quite straightforward. As I mentioned, you need to have a Reset Grade B certified, a monitor that is part of the Works with WELL catalog. That's a very easy way to check those two criteria. Will probably be compliant. Not necessarily with every feature, but at least with the basics. Now, other certifications will have different requirements. Deployment size, this is really important. Different certifications can have very, very different densities of monitors required, and this will, of course, have an impact on your budget. I'd say the ideal solution needs to not only meet these basic requirements, but ideally should also provide other ways to increase ROI for you. So even if we're looking just within the sort of narrow realm of certifications, within WELL, there are preconditions, but there are also a lot of optimizations. So the ideal monitor should not only satisfy the preconditions, but should also be able to help gain more points in across the optimization features. So that's kind of one use case that we see a lot. Another one is improving building operations. And again, if this is your only goal, then your selection criteria are actually going to be very different from if you're going after a building certification. If your focus is on building automation, then how these systems integrate with each other is probably going to be your first order of business. So the question I would ask is how is your building set up? Make sure to talk to your controls engineer and actually understand what integrations are possible, which ones are not. And you're probably going to be looking at, for example, monitors that have BMS-related certifications, such as BTL from the BACnet testing labs. If it is supporting an integration to the BMS, is that through BACnet? Is it through Modbus? Is it BACnet IP, BACnet MSTP? Does it go through the cloud? Hint, building engineers do not like BMS integrations that go through the cloud. They like everything to be local. So there's a lot of important points in there that it makes sense to connect with your building engineering team on to make sure that you narrow down the selection that they can actually work with and not bring them something that's going to cause headaches and just lead to roadblocks when you try to roll it out internally. A more generic goal that we see is wanting just to improve health and well-being of occupants inside the building. And if this is your only goal and you're not going after certifications or integrations, then the starting point there is to think about what are the parameters that you would like to measure, how are you going to measure them, how are you going to report on them, how are those going to translate into metrics around health, around productivity? Can you extrapolate that raw data into metrics like those that matter? Will you use occupant surveys? Will you use occupancy data? There are a lot of other aspects that live alongside indoor air quality in delivering a superior occupant experience and creating a healthy environment. So you want to know that once you have that data, you can do something with it. And you're not just going to be left with a lot of CO2 and PM 2.5 data, because trying to translate that into health metrics yourself, we've seen to be a challenge for the vast majority of organizations. It just adds another layer of complexity. So if that is your goal, then that will also impact what you're looking for in a vendor. And I think there's a lot of questions that you can ask when working with potential suppliers to make sure that they can actually help you in this journey of translating raw air quality data into the metrics that matter for you. Another factor related to this one is to think about data access. So we have lots of clients that want to publicize their data. That might be raw data, it might be some sort of aggregated averages, it might be reporting on investments that have been made into the health of occupants as a result of the data from air quality. There are a lot of different ways to take this information, translate it into something that can deliver value to your occupants, and there's many different technical ways to implement that. So again, if that's something that you're interested in, make sure to talk to your potential vendors about that and make sure that they actually have a strategy and are able to help you accomplish those goals. So we've talked about the first lens, which is, I say, stepping back, getting a big picture of the project and understanding project goals. So that tells you what you want to shoot for. The second lens that I'd always look through is, what are the limitations? What are the constraints? And what are the preferences of the other stakeholders that are involved in this decision? So the reason why you should evaluate these constraints and preferences is that you need to understand what's actually possible. So if I go back to the fitness example for a moment, you might have a plan to lose weight, and that's amazing, but if you have serious chronic knee issues, then maybe running is not the best training plan for you, and maybe you should go for something like swimming, right? And so making sure that you understand your goal and then making sure that you understand the constraints under which you need to operate will again help you to narrow down all of the potential suppliers and vendors out there and the different potential solutions and ways to set up your solution into a handful from which you'll be able to make a good and educated decision. So there are a few main categories that you'll want to look at. So, first one is power. So there are really two options here: hardwired and battery powered. And choosing the right one depends, well, actually, there's also a third option, which is USB power. And I say that's kind of a third option because that's generally more of a backup solution. Ideally, if you're going with a proper deployment of air quality monitors, you don't want to be doing this with USB cables, because somebody can just walk along, unplug the cable, plug their phone in, and forget to plug it back in. So it's a useful option to have, but really, ideally, you are looking at either a proper hardwired solution or battery power. And the right one for you depends on what stage the project is at, usually. So if you have a new build, then hardwiring is generally quite simple. During construction, you can make sure that there are cables available, and it will be very simple to configure and get that monitor connected and online. But if you're working on a retrofit project, then running new cables can be extremely disruptive, it can be expensive, and it can be a real headache in a space that actually has people operating in it, right? And so in that situation, a battery-powered solution might be the best. So, pro tip, I think PoE is a great solution. If you have the ability to use PoE, this can be a really great option. So next up is connectivity. There are many ways to connect your monitors to the network to transmit data, but start off by seeing if your building requires a certain type of connectivity. For example, if you must use Ethernet, then you don't need to think about other options, right? Cellular or wireless. I've seen many projects where the workplace experience team or whatever team is looking at rolling out air quality monitors gets really far down the process, selects a vendor, selects a solution, selects the product, and then finds out that the IT department has something to say about it. And at the last minute needs to either change product, change vendor, or similar. So it's really important to find out what the constraints are, both around power and connectivity, early on in your journey. Now, if your building doesn't have specific connectivity requirements, you have flexibility, which is actually really great. You can choose to connect to the existing building network, which has some pros, or you could choose to work on a totally separate network. So, for example, a fully wireless network that has a cellular connection, so that the devices are not sitting on any network in the building, and this can often save a huge amount of time going through IT InfoSec review, because in many organizations, if the devices are not connecting to the building network, then they are out of scope, and that can massively increase the speed at which projects can be rolled out and the time to value delivery. So this is definitely something worth thinking about early on, because it will influence pretty much all of your decisions. Another factor to consider is installation. So your building might have certain requirements for installation. For example, if you are in a building which has a ton of meeting rooms and they're all beautiful and they're all glass and there's not really any walls, then that really limits what you can do in terms of the type of monitor that you install. In that situation, you would absolutely want to go with a monitor that is battery powered, fully wireless, and there are no cables running around, because trying to run a cable up a glass wall, not a good idea. If you can pick and choose where your installation will be, what locations you can use for the monitors, then there's a lot more flexibility, and you can start to think about things like the location. Do you want the monitors to be on the wall, on the ceiling, on the tabletop? So make sure that those placement guidelines are thought through early on. Again, I've seen many projects fail because of miscommunication about where these devices were going to be installed. At the last moment, the designers looked at the device and said, there's no way that's going on the wall, I need it to be on the ceiling, and the device is impossible to be installed on the ceiling, or there's no cables there. So again, generally there's a lot more flexibility with a battery-powered wireless option that you can just peel and stick onto any location. If at the last minute, for some reason, you realize that it can't go on that wall, it needs to go on that wall, that's fine. It's a lot harder if you've just run cables down the wall. Finally, there's a question of complexity around installation. So an important question to ask is, who's doing the installation? Is it going to require a third-party install team? Can it be just done by an office manager? Can it? Do you need to have an electrician come in? Do you need to open up the drywall, or can this simply be stuck on a wall? Again, understanding and there's no right or wrong answer here, but it's important to gather all of this information so that when you're going through that selection process, you can actually ask these questions to vendors as well, and understand the potential complexity of install and whether or not that's actually possible in your specific project. Now, the last one I want to touch on here is maintenance. All air quality monitors need some form of maintenance, whether it is battery replacements on battery-powered devices, or if it is sensor recalibration, which is particularly important if you are pursuing certifications such as WELL. So thinking about how to deal with maintenance and exactly what is involved early on is going to pay massive dividends in the long term. Because making the wrong decision here and having a device on your wall where the batteries need to be changed every year, or where it's physically impossible to recalibrate can be a very, very expensive problem to have. And you don't want to find yourself there a year or a year and a half down the road, suddenly questioning whether the right decision was made about the type of devices to install. I have seen many projects actually end up in that situation where 1 or 2 years down the road, monitors are being ripped off the walls and new ones are being put on because of decisions that were made that were maybe suboptimal. Okay, now we've covered sort of the two lenses through which I would recommend evaluating your project. So that's goals and then the physical requirements, constraints, limitations. Hopefully, the ocean of air quality monitors and potential solutions has now been narrowed down to a handful, 1 or 2 or maybe 3 that are actually able to deliver on your goals, satisfy all of the requirements. So now we get down to kind of the fun part of how do you really compare these side by side and try to make the right decision. At Kaiterra, we have 3 best practices for making this decision. So first one is parameter selection. Now, even if you are wanting to monitor IAQ for health and well-being, many people still choose to look at building certifications as kind of a reference for what to measure. And so here we have a chart that we've made to summarize the parameters that are needed in probably the most popular building certifications. So you can see here what points you can get with which parameters and which parameters are required versus optional. So whether you are doing a certain certification or you just want to use this kind of as a frame of reference, I think this is a really useful table that you can use as a guide to choose which parameters you should look for. And again, we see a lot of projects that are not going for a specific certification, but choose to use these certifications as their third-party objective standard. I would absolutely recommend doing this rather than trying to come up with a standard internally. Huge amount of research has been done by these standard bodies and the certifications, and I think it's very hard for your average buyer or a company that is interested in measuring air quality to do the same quantity of research that has been done by these certifications. Second best practice is around how to choose between hardwired or wireless battery-powered solution. And in short, the benefits of a hardwired solution is that it's stable, it requires virtually no maintenance once installed, and so really you plug the cable in, you put it on the wall, and that's that. You're done. The cons are, of course, that installation can get expensive. It can create disruptions. Often it needs to be done at nighttime. You may need skilled labor, which may not be immediately available, and so on. These can be a bit tricky. If you are going with a hardwired option, I absolutely recommend using Power over Ethernet, PoE. Is one single cable that gets plugged into the device, takes care of the power, takes care of the networking, and the device essentially requires 0 configuration. This is potentially not true of all PoE devices, but at Kaiterra, for example, it is plug in the cable and that's that. Again, it can be expensive. So for wireless battery-powered solutions, really the benefits here are that you don't need to deal with wiring. So you don't need to pull cables, you don't need complex installation. Install is very, very easy. It's very, very efficient. There's flexibility around where the device goes, and if you ever reconfigure a room or you realize that you had it installed in the wrong location, it's a very easy thing to fix. The cons on this front, though, are there's the potential for connectivity to be less stable. You will also have to replace batteries in the monitors, right? The batteries don't last forever. So if you are retrofitting a building or if you have a large installation, I do recommend going with a wireless battery-powered solution. It is much, much faster at scale, But if you are going down this path, then definitely choose a solution that has long battery life. Imagine having to change your batteries every year. Imagine that you have 200, 300 monitors across a building, a large building. Each one of those maybe has 6 batteries inside. You're looking at potentially almost 2,000 batteries that need to be replaced. So doing that once a year is a huge amount of work. It's a nightmare. It has a large environmental cost. If those batteries last for 8 years, that is a very different proposition. So make sure to choose a monitor that has a really long battery life. The third best practice is to choose the right level of data analytics. So software is incredibly important when it comes to air quality monitoring because it gives you the tools that you need to actually put your data to use. So collecting, analyzing, and interpreting your data, ultimately you need to take this data and you want to turn the raw data about air quality into value to your organization. And that is not done by the hardware, that is done by the software that will capture this data and process it. Unfortunately, many projects out there don't give software the consideration that it really deserves, and unfortunately I've often seen it being thought of as kind of an afterthought. Buyers will often think, I need an air quality monitor, therefore I will look at these technical specifications and I will choose one. And what happens with that data that's a problem for someone else down the road. This is a recipe for failure. You are definitely setting the project up for failure if you go down this path. And unfortunately, I've seen it happen many times before. If you choose something, a solution that does not have enough analytics, you will either need to custom build your own software, which is expensive and time consuming, or you will find yourself sitting on a mountain of data and probably not using it. Ultimately, not going to be a successful project. So I would say absolutely at the start of a project, at the same time that you are evaluating the hardware, you really need to be digging into the weeds of the software and understanding how this data will be translated into the value that your organization is looking for. Here is how I would suggest going about this process. There's kind of 4 levels of dashboards for data analytics and access. So level 1 is very basic. It's just raw data in a CSV file. There's no summary, there's no visualization, and that's about it. Level 2 will give you some basic visualization, so trend graphs. Maybe you'll get 2 lines on a graph together, but that's really it. There's no further sort of data aggregation or anything like that. Now, level 3 is where you start to get into more advanced analytics. So you might have different charts, heat maps, data summaries, maybe some specific insights. And this is where you can actually start to translate this raw data into meaning. Level 4 is really going to go a step further than that. It's not only going to analyze the data, but also do things like provide recommendations, provide reports, provide weekly insights, automation, and really help you get to the root cause of what issues are and help you to actually resolve them. So I think that's where we start to go from having data to having better air. And my view is that for the majority of customers out there, the reason why you put in air quality monitors is because you want to have better air. It's not monitor air for the sake of monitoring, right? It's actually to create better health outcomes. And so if this is something that you care about and is a goal of your project, then level 3, level 4 is probably where you want to be. There's different data levels, and different projects will have different requirements. So we've kind of summarized it on this slide here. So level 1 is good if you have a couple devices, you are using them offline, or you are connecting them to the BMS, and you will run automation on the BMS, but you don't want any sort of analytics. Or level 1 can be acceptable if you have your own data analytics team on site that is going to create its own dashboard. Word of caution here, I've seen many projects fail because buyers intended to do this and planned to build their own dashboards and aggregate data from many sources into one, and never ended up doing it. Level 2 is best if you are just getting started, and again, maybe you just have a couple devices, you want to see some basic graphs and kind of understand a little bit about how air quality works, but at a very limited scale. Level 3 is going to be a lot better for large commercial projects, or if you have very specific goals for your air quality and you need more granular data. If you are a global real estate leader, sustainability leader, you have 16 buildings, each of them has 100 devices, you will need at least level 3 when it comes to data analytics and a dashboard, because trying to get any type of insight from time series graphs with multiple lines going up and down is virtually impossible and will probably drive you crazy in the process. So having something like this is, I would say, an absolute minimum if that is the type of project that you're working on. And level 4 is, of course, best for projects that want to actually improve their air quality and not spend thousands of hours trying to analyze the data themselves. One of the areas that we have seen a lot of people fall over on, and I hope that fewer companies can follow in those footsteps, is assuming that there is in-house expertise and this is just a data analytics question. The reality is that indoor air quality is a data analytics question, but it's also a health question. It's also a question of physics, building physics. It's a question of environmental chemistry, and it's a question of the interaction of all of these. And so make sure to think about what the goals are and assess whether that is expertise that you have in-house, would like to develop in-house, or would like to use a third-party consultant for, would like to rely on your air quality vendor for, or whatever it is. These are all viable options, but I would definitely recommend thinking about it at the start rather than at the end of the journey. All right, to close out this video, hopefully you have found this useful. I've put a little cheat sheet together, and you will see some of these best practices here. So you can go ahead, pause this video if you want, take a screenshot. I will not bother repeating everything that I just said. Hopefully this was useful. This is personally how I think about choosing air quality monitors for projects. These are the criteria that I will look at when trying to assess what is the right solution for a specific project. Hopefully you found it useful. Feel free to reach out. Don't hesitate to send us a message, send me a message, and hopefully you're able to choose the right air quality monitor for your project.